Hello everyone, welcome to Learn Overflow. In this video, we'll discuss another LeetCode problem, that is the delete middle node of a linked list. This is a medium type problem and we'll understand how we can solve a question like this. So before moving on, if you haven't subscribed to this channel, make sure to subscribe to Learn Overflow for regular LeetCode videos like this. The question says, we are given the head of a linked list, okay, and we need to delete the middle node and return the head of the notified link list. So we just return the head, but in the meantime, we need to delete the middle node, right? So that's our target is. Now, what it means by middle node, the middle node of a linked list of size n is the n by 2, like n by 2th node from the start of the zero in like zero based indexing, where x denotes the largest integer less than equal to x. Okay, so that's what it is. So let's understand that. So if there is like 7 nodes, okay, zero based indexing, so like it starts with 0 to 6, so that's like 7 nodes. So 7 by 2 is more or less, as you can see, 3.5. So in 3.5 it will be like, you will find that the box of x is given, so n by 12 box, so that is equal to the 3, that the zero based indexing is going on. Okay, this is the largest integer less than equal to x, right? So like largest integer less than equal to 3.5 is 3, so that's what we get, 0 1 2 3. We're removing this one. Okay, so that's the integer we are removing. Now, that's how we're just going on. So everywhere we'll be finding out which index will in remove. So I hope you can understand, like more or less it wants us to understand that we need to remove the middle one. Like as you can see, there's like 7 nodes are there. So 3 on the left, 3 on the right, and remains the largest one. Like this one is getting removed. Fine. So that's what we need to do. Even in the second case, you can see there's like 4 integers. Like 4 by 2 is 2. So that's 0 1 2. So that's 2 is the second one you are removing. Right. So this is the idea. Now, the basic question is how we should go ahead with it, right? How we should find a solution to this kind of question. This question is like kind of like pretty easy, not like so tough. But the thing is, we can have 2 3 different ideas to solve this. Let's just understand them one by one. Say we have this whole linked list. In the linked list, we don't know the length of the linked list, right? So what we can do is we can simply say in the first run, we can go through the whole linked list and find out the total length of the linked list, like how many elements are there. And whatever be the length of the linked list, we will like run another loop, length by 2. Okay, so once we got the length, we'll do another loop like length by 2, and in that we'll just remove our desired node. Okay, so that's a pretty simple idea. But this idea is an order of n solution. But the thing is, can I improve this? Because we are going through the whole list near about 2 times an order of n loop, right? Once we are calculating the length, the whole length is getting calculated. That's order of n, and then again we are calculating, like going through the whole linked list, calculating the half of the linked list. That's again an order of n, right? So there are 2 times order of n, though the total, like the effective order of length or the complexity remains to be order of n, but the thing is, can we reduce these 2 loops? The next question comes. Yes, the answer is yes, we can remove these 2 loops. So how we can do that? So that's a better kind of solution is, how we can do that? We will take 2 pointers, basically 2 pointers in the sense, one we'll call a fast pointer, one we'll call a slow pointer. How this would work? Initially, our head is pointing to this position, right? So we'll say our slow pointer will be at this point, and our fast pointer will be noted to head dot next dot next. So head dot next is 1, and then dot next is this. So we are initially marking a fast pointer over here. Okay. Now see what these 2 pointers will do. These 2 pointers, like in case we need to check in case this is a valid node or not. Okay, that's when you check. Say there's only 2 elements, so that in that case that's not a valid element. So those checks are necessary. But see, like if valid, then what we are going to do? Simply we just simply placed these 2 pointers over here. They are pointing to different elements. Now what's the idea? The idea is our fast pointer will always keep one node and move to the next node. Okay, always keep one node and move to the next node. Fine. And our slow pointer will travel to each of the nodes. Fine. So that's what our slow pointer is supposed to do. But our first pointer is supposed to skip one node and move to the next node. Okay. So what's the utility of this? The utility is simply, Whenever slow pointer travels one step, our fast pointer is traveling two steps. So more or less, whenever our slow pointer is at the middle, like in the middle, our fast pointer is at the end, right? Because it's just doubling the number of steps we need to travel, right? And our slow pointer is like going slow. So that's the just keeping a distance and making it half of the traversing it half of the list. How the traveling? Let's understand. So in the first jump, our first pointer will be in this position one. Okay, but a slow pointer will be at this position. That's a single jump. This next step, our first pointer reached to the last element, like the six, but our slow pointer reached to the four. Now our fast pointer cannot go ahead because there's a null, right? There's a null, we cannot go ahead. In that case, once we cannot move forward with the first pointer, our slow pointer is standing just behind the element that is supposed to remove. We are supposed to remove, right? So what we will do, we'll say slow dot next equal to slow dot next dot next, right? So we just like broke this link and connected it to our four, like the next element. Okay, so then we our new linked list don't have this particular element in it. Fine. Let's understand in a like this kind of scenario. Our slow pointer is initially over here. Our fast pointer is initially over here, right? And what we did is like slow moved one step and the first moved to one step, right? So why the like what where our checks are? Our checks were basically two things. One, whether our first is null or not. So our first should not be null, right? So that should be a one of the check. And the second check is should be the first dot next should not be null. Okay, so that should be our check. So is the check valid? Our first was standing at this position. What is fast dot next? 4. That is not null. We find a node. What is first? Is our first is currently at null? Like it's no. First is currently at this node. So is our first null? No. So in that case, we can actually jump. And after the jump, we find our first being null. So that's the break case where we break our loop. Okay. So once you break our loop, like that's the break case. So in that case, what happens? Our slow is currently standing at the position that is supposed to be because the next element is the one that is supposed to we're supposed to remove. So in that case, we simply do slow dot next. So we just marked it to that. We just broke this link and connected it to the next one. Fine. So this is a pretty simple idea. So in that case, what happened in this particular step? We are not traversing the loop or we're not traversing the whole linked list twice. Rather, we're just traversing the whole linked list only once. That's a order of n. Even that's an order of n, but we're traversing it only once, and the steps are only going on only once, right? So I hope this is pretty easy and pretty fast. So in an interface scenario, if you go ahead with a step where you are calculating the length or the counting the number of nodes in the linked list, the interviewer may ask you to just improve the solution. So the improved solution will be using a slow fast, like a slow fast pointers. Okay, so this is the solution. So you simply go ahead and write the solution, and then you will understand. And again, how this solution that we wrote is comes works exactly what we are trying to do. Fine. So okay, so this is the solution we have. Let's understand this, how exactly we wrote it with what we are understanding this. So first of all, we checked whether our head dot next is null or not. So what this check means, it is checking whether we have only one element in our linked list or not. Okay, so in case our like the list has only one element, so in that case we are supposed to return null, right? So there's no point finding anything. In the next case, what we're doing, like now we're sure that there's at least two elements. Once this check is passed, we are sure that there's at least two elements, fine. So we're doing that slow is pointing to the first node, and fast like this fast pointer is pointing to the head dot next dot next, so the third node. Okay, so that's what it's going ahead on, like as we are discussing it now. So first is pointing to this node, and then slow is pointing to this node, fine. Now what's first? We're checking for first not equals null, and first dot next not equals null. So this two checks were for two different purposes. One, when first not equals null, so that means it's like if this check becomes true, that means what that means is like if if this check becomes false, that means our number of nodes in the linked list is four, is like even number, And if this check becomes false, that means the number of nodes in the list is like odd number. So that's the check we have. Fine. That's simply the check we have. Now, that's what we are checking, because when we'll see like this in this example too, because slow is over here and fast is over here. Fine. In the first step, slow is going to the true, and then in the next step, like fast is going to null. First is becoming null. So first is becoming null. We are breaking it. We're not going farther with it. Fine. And then we are just moving this slow dot next equal to slow dot next dot next. That's what we're doing. But when this fast dot next becoming false is the case in this. Okay, so fast move to this position in step one, slow move to next position this step one. In the step two, fast move to 6, slow move to 4. That's step two. And after that, what we're checking is just checking is fast dot next. Fast dot next is this link. This is null. This is null, right? So that's where it is breaking, because this will be working in that format, right? So this is the two things we're just checking. If either one is becoming null, that means we have reached our endpoints. We have reached the ends. Okay. So this is how it works. And like unless it is not null, like it's going on, what we're doing, we're moving fast 2 step, and we're moving next 1 step. Fine. So that's what we're doing. Yeah. So that's what we're doing. We are moving fast 1 step, like 2 step, and slow 1 step, fine. And then what we are checking, we're simply not checking, rather we're just doing the important task. And this is the step to remove the node. Okay, like the deleting the middle node. That's the task we are given. So we're simply deleting the middle node over here, and further we're just returning the head. That's what we are mean, right? Return the head of the modified link. So that's what we did. And you saw like this is a pretty fast solution, right? And in that case, it's showing us 5 ms, but this LeetCode attempts is mad with this. See, it just went down to 3 ms and it becomes 100 ms, 100% faster solution. So this is, yes, it's definitely a faster solution you can have in this question. So I hope it is understandable how you can solve this question. So thank you all for watching this video. Hope to see you soon in my next video as well. Also, like this video and subscribe to this channel for regular LeetCode videos like this. Thank you all for watching this video. Thank you.